thought I'd start doing some shorter videos to show some of the workflows that I've been doing in Dynamo and little bite-sized pieces of code. Today I want to show a little bit something about moving parameters around in a file. I've got a bunch of families here. These are adaptive components they happen to be. You can do it with anything, but this just sort of makes for better television. These are all, here, I'll just turn this Dynamo graph off for a second and show you what this file is. So what we've got is a surface that has been panelized, and each one of these panels, if you tab into it, you can see it has an opening parameter here, and if I change this guy I can adjust what the size of it is. If I select all of them like that, I can change all these guys back to be the same thing, and they pretty much work between a value of 0.1 and 0.4 to get interesting changes in these surfaces. So if I go back and let me get my Dynamo back up here, what I'm doing with Dynamo is I'm automatically manipulating all the parameters here. In particular, I'm going to do a randomized set of values so that if I start monkeying with my slider, I can get random associations of parameters being driven into each one of these families. And there's a simple way to do it that doesn't have a whole lot of flexibility, and then there's a more complicated way, which is pretty cool because you can do various random associations. So right here I've got a integer slider that goes from 0 to 10. So basically I've got 11 values I can put into this thing. And actually, let me reduce this just for clarity. So now I've got 5 values from 0 to 4. And if I go back and forth between those different values, you can see different random sets of parameters getting driven into all of these families over here on the right. So what it means is that I can actually find a particular random set that is to my liking. So here I've got these sort of 3 big open ones here on the left side, upper side. I can explore some other options that might be more to my liking, but whenever I go back to 0, I know that I can always find that first set of random associations. So how do we do this? I'm going to turn off run automatically for a second just so that this isn't constantly updating. What I want to just show is a couple of nodes here, and I'm just going to take this thing apart and then put it back together. So let me unplug these guys and we'll talk about a couple particular nodes. So just looking at these guys, what I've got here is a selection set of nodes, some math manipulation, and then writing out 2 family parameters. So over here on the right, family types. This is a picker. So basically I can get a drop down from the family types and I can pick any of the loaded families that are in this particular project. Here, this is in the mass environment. You can do the same thing in a project environment, but the idea is that anything that's loaded into the Revit file, you can pick from the family types picker. Now, this is actually a selection node. That is, this will put into the Dynamo selection anything that gets piped into it. So all elements of family type. There's a bunch of nodes that are like this. If you go into Revit selection, you'll see all elements at level, all elements of category, all elements of family type, da 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 da. There's a bunch of things where I can go and I can directly select particular model elements or particular faces, but what I want to do now is I want to get all family types of this particular aperture panel. So if I look at this with a watch node, you can see what's spilling out of this guy. So here, if I pipe that one into my watch node, I can run it and see that I've got a whole crap load of families. 36 families that are just going to be selected. If I open this up and run it on another file, it'll pick out as many of these. If I have aperture panel in that other project, it'll pick all of them out. But right now it's just picking out the ones from this particular project. So now that I've got all of my families in selection, I can do stuff to them. And how do I do stuff to them? There is an element set parameter by name. So there's two things that you can do that are sort of primary use cases. There's get parameter value by name, and there's set parameter by name. So if I take a particular name of a parameter, and here I've got a code block node, I can also just take a string value and say, give me the, let's see, what other parameters do we have with this guy? If I look at this guy, I've also got, I have a area value. Let's just look at area value for a second. I can say area. And if I put area into the parameter name and I pipe in all of my elements, what I will get is all of the areas that are recorded for each one of those panels. If I put in that other parameter that we were looking at, opening, I can run that and I can get, oops, opening, oh, case sensitivity. So opening is lowercase, so I need to put in opening like that. And now I'll get all those values that I already wrote into all those parameters. So this is get. What I want to do is I want to set it, because I want to manipulate these parameters. So the other thing I'm going to just show you is that I've been using a string value here for this example, but you can also use a code block and just put it in quotations. So code blocks, just a real convenient way to put data into anything. There's a whole lot of things you can do with code block nodes, but just for simple data entry it can be very useful. Double click, you get a code block node, and if I put something in quotations it becomes a string. Opening. And then you end with a semicolon. And that's all I'm doing here. So these two nodes right now are doing exactly the same thing. So anyway, now, rather than getting parameters, I'm setting parameters. So if I say set parameter by name, and I say what parameter? Opening parameter. And then I just need to give it a value. So right now what we're seeing is all these guys have random numbers written to them. I can go and set them all back to a shared value. So I can also double click in Canvas here. I can say I want them all be 0.2, say. And if I put in the value and run it, it's just going to return everything back to the same value. Now, starting to get into randomized numbers. Rather than doing just a value, why don't we give it a range of values? So I can say range, I can get a number range, or I could also do a number sequence, which are sort of different ways that you can start a series of numbers. So if I say, oops, so if I say I'm going to start at 0.1, that can be my start value, and I can say my end value is going to be 0.4, which is what we identified before as sort of the meaningful range of these nodes, and a step value. This is where, you know, there can be a little bit of fudging, like, I don't know, that's going to be some very small value, 0.01. Because I've got 36 of these things, what is that going to give me? That's going to give me probably not quite the right number of values. How many have I got? 30. Close enough. Let's call that close enough for now. I'm going to show you a better way to do it in a second. So I've got my 30 values. I can pipe them in now, and when I run this, now what I'm going to get is I'm going to get a gradation of values going into all of these nodes. So let's see, let me give it a slightly finer grain, 0.075. And so now what it's doing is it's taking that series of fractional increments and writing that out to each one of these panels. So I've got 0.1, 0.08, 0.15, slowly growing, right? So those values are all going into all of my elements. So now I've got all of my families that are now getting this different value written to each one of them. Boom. So now I can see that in the order that they were created, or the order that they're coming in here, they're all getting these value assignments, so it makes this gradation. Now, but what I want to do is I want to do something that's random, right? Well, the first thing I want to do actually is I'm going to give myself a slightly better list. So number range is all good and well, but there are more efficient ways to do this. And this is with a code block. Code block nodes have a really cool number syntax tool, which allows me to go in and do things like this. I can say, I want to give it a start value, like we were doing with our sequence before. And if I do ... that means that I'm then making a range of values. So I'm going to say, I want to go from 0.1 to 0.4, right? And then I can say ... how many pieces do I want? If I say number 36, because I know I've got 36 elements in here, what that's going to give me is 36 values evenly distributed between 0.1 and 0.4, which is a little bit cleaner way of doing what we were doing before. I just know that I will have the right number and I don't have to guess at what the increment is going to be. Dynamo will just figure that out for you. So now it goes through and it makes a nice clean distribution of all those numbers. All right, still have not gotten to random, right? So if you look at random, you get a bunch of different kinds of tools for making random number assignments. And the first one I'm going to try out is one called shuffle. Shuffle, as its name suggests, is it just shuffles a list, randomizing the order of the items. So now I know I've got my values from 0 to from 0.1 to 0.4, and now I'm just going to shuffle them. So this will be a one-shot deal where I can basically just take all of these values and then they go from a smooth gradation to just a jumble. I know that I have all of enough values and I know that they're all going to be different from each other, and now I have random assignments for all of these things. The problem is that this is just sort of a one-shot deal. It's relatively simple. That is, if you look at what you're doing here, you're making a list of numbers, you're shuffling them into a different set, and then you're passing them all into these families. So this is all cool. I can do one shot, I can get a random assignment, but maybe I want to get a different kind of random assignment, and this is where it can get a little bit more complicated. So what I'm going to show here is a more controlled version of doing a same kind of thing, of having a random number assignment. So this other jumble of noodles down here, what are these guys doing? Well, the first thing is there is a tool called math random, which is random with a seed. So what does that mean? If I just take this guy and look at what it does, math random. So if I take my integer slider, which, you know, as its name suggests, is just going to give me whole numbers of whatever range I want to put in. If I put this guy into math random, what it basically gives me is I get a random number based on a starting point to random from. So here I've got 0 and 0.726. If I go up one, and let's run automatically now just to show this, I get 2.49 and so on. And basically it's giving me a random number based on this seed value that lies between 0 and 1, which is pretty cool because I want something that's sort of in that range. So what happens if I give it a sequence of numbers like what we were doing before? So double click, I'm going to do 0.1 ... 0.4 ... and give me 36 of those. So now I've got 36 numbers that are going in between 0 and 4. That can be just fine, except it's going to be a little weird because it would like to get integers, and I'm giving it numbers that are between 1 and 4, and so it's basically just seeing all of these as 1. What if I give it a series of integers? So we go if we say 0 to 36. I can do 0 to 36, do 0 to 35 just straight up, right? And now I've got 36 numbers that are going to actually go just in whole numbers. If I don't actually specify the increment, I can get whole numbers like that. And now what I've got is a list of random numbers generated that are between 0 and 1. Alright, so now we're starting to get somewhere with a controllable set of random numbers. That is, if I now change this from 0 to 35, I could say, let's start at 10 and let's go to 45. What this is going to give me is a different set of random numbers because I'm giving it a different seed or a different starting point. So additionally, what I could do is I could say, why don't I give it a starting point of x and an end point of x plus 35. What this will give me now is I've got an input. I've got a variable input. The code block recognizes that. So now I can say, I'm going to give you different starting points for your random numbers. Now I'm starting at 2. Now I'm starting at 3. Now I'm starting at 4. And all of these are going to give me different combinations of random numbers, which is cool because now I can actually have different sets of random numbers to all send out. Right? So far so good. Except that this is giving me random numbers that go between 0 and 1. And I don't want 0 to 1. I want a range from 0.4 to 0.1 to 0.4, right? So this is where this guy comes in. Oops, where did I just put that? I'm going to look at a node called Remap Range. Remap Range is also a nice, awesome little tool because what it allows you to do is say, I've got a bunch of numbers that are coming in a certain range. What I want to do is I want to have that same sort of spread of values and same distribution of values, but I want them to all fall within a specific range of values. So to show you this in a slightly different way, let's just take another list of numbers, 0 to 9. Now I've got a value from 0 to 9. And by default, what this does is it remaps that range of numbers from a minimum of 0 to a maximum of 1. So now I've got 0 to 9 being remapped into that range. I can also say 0 to 9, but give it to me in the range of 0.1 to 0.4. So now I've got 10 numbers that are being remapped into that range of 0.1 to 0.4. So you can see we're starting to edge in on what we want to do for generating random numbers for our families. So rather than getting 0 to 9, I've got my random number source here now. My random numbers can now be remapped into that range that's appropriate for my project. Now I've got random numbers that are going between 0 and 0.1 and 0.4, and I also have them hooked up to a slider so I can keep generating new lists of random numbers. So what does that mean? Now I've got my list of random numbers that are 36 in total, and if I move my integer slider, I can get different sets of random numbers. So we can take this now and we can just pipe this into our values. It takes a second to sort of warm up and think about this because, you know, Revit parameters, they're awesome, you love them, but they're a little pokey sometimes. So now I'm going to just sort of clean up my file a little bit here and look at my tidy little block of 5 nodes, which are going to give me some awesome random numbers. I can now go and slide through these things, and you can see all of my families updating with my random number selection. And if I'm not seeing the option that I want right now, something that really fancies what I want to do with my design, I can just increase this. I can just say, I want a bigger range of random numbers. And now I've got 100 different, actually 101 different varieties of random numbers that I can create here by just sliding up into sort of higher ranges. Because every time I slide it into higher ranges, it gives me a different seed that I can start out my random number assignment. So now I'm starting my random number assignment at 27, and then I'm adding 35 to it in order to get more and more random numbers. So that's the kernel of it. I had a couple other things here that I'll just show this stuff just because it's kind of interesting. You can also do some things with rounding. So right now I've got all of these are basically unique values. So now every single one of these panels is a different one. I can do some stuff with rounding just to limit the number of variations that I've got. So right now, because I'm generating this out to 3 decimal places, it's pretty much guaranteed that every single one of these things is going to be a different panel. I can round these numbers down, and I can give it how many digits I want. So if I say 0.1, what's going to happen now is I'm going to get, whoops, what am I doing here? Oh, I gave it a 0.1 rounding, which was jumping ahead. I want to round down to 1 digit. So 1 digit is going to basically take that list that was, quite fine-grained at 3 decimal points and take it down to 1 decimal point. So now I essentially have 4 variations. I have 0.1, 0.2, 0.3, and 0.4. So if you are a shrewd designer who would like to have variation but not break the bank, now I've got 4 variations on my panel types, which are again randomly arranged, but there's only 4 different panels here. So I can say, okay, I've got panel type 1, type 2, type 3, and type 4, and we're done. And again, these are still random assignments, but there's just a limited range of what kind of variety there is. And I can still do the same thing with my slider of making them different arrangements of those same 4 panel types, but it's still just 4 panel types. So again, if you just look at the whole definition here, we had the simpler way of doing it with just shuffle to get it going. But now with a more complicated set of nodes, what you get is a bigger payoff basically. Now I can say I can have a set of nodes, make a random set, and then I can make more random sets, and then I can also keep them contained within a certain range of variation. Here I've only got 4 variations. Anyway, these data sets will be available online on the blog, and I hope that this was a little bit helpful for you. Thanks for watching.